Uh, okay, let's get started. Before we get started, please have a check of the mark for the lab 1 and 2, 3. Make sure you got all the marks. If you don't, send me an email, please. Yeah, and we may have some trouble on the submission. For example, some file may corrupted after the submission. So if you find the mark is wrong, please contact me as soon as possible. Simply click this link to check your grades. Let me copy this link. The chat. Okay, please let me know if you think there's something wrong with your mark. Okay, let's get started. Lab 4. Before we open the lab 4, we need to do some preparation for the lab 4, which is the Wireshark. So just go to the web page and type Wireshark like this. What happened? Let me check. Okay, so simply download it through the button. Yeah. So install the latest version of the Wireshark. If you are using the Linux, you can search the installation command online and install it. Should be easy for you. So I assume you have already installed it. So it will be something like this after open it. So what is Wireshark? Wireshark is like an agent between our computer and the server. So once we send a packet to the outside to a random server, it will go through the Wireshark at first. So the Wireshark can observe or analyze the content of the packet from our computer to the outside, or from outside to the computer. That's how it works. So in order to capture the traffic from our computer to the outside, you need to at first select the interface you want to observe. In here, I only select the Wi-Fi interface here and click the start button. And you can see there are lots of packets every second, right? And then I can click the button stop. You can see around 15 seconds, we got about 3,000 packets. So that's a lot. Then you can see there's some content inside here. The source IP and the destination IP. Obviously, this is my computer. And this one is, I guess it's the Zoom server. And you can have a check of it. But I think so because it is using the UDP protocol, because we are streaming the to lab right now. So that's how we use Wireshark to capture the traffic from our computer to the outside or outside to the computer. And yeah, so what can we do with this kind of packet? We can save this stuff as a trace file. Simply save it. And what can we do? The first one should be apply a filter, because in here we only want to analyze, let's say, the TCP packet. So we can apply a filter here. So all the TCP packets will be showing here like this. So if you want to apply more filters, like what if I want to figure out the outflow packet, which means from our computer to outside instead of outside to our computer. So what can we do? So we can select the IP address of our computer, this packet, can you see that? And we can just simply find the IP address in here and right click it. Then you can see lots of options here. The first one in here is the apply as a column, which means you can show it on the column, but I will show you later. But in here, we only want to apply this as a filter, right? So select this one, apply as a filter, and select it. So it will write something on here. So you don't need to even know the syntax of the filter. Just click your mouse, then you'll be able to like apply a filter here. And you can also apply a different condition like this, apply as a filter, apply as an and selected. So the packet must follow these two conditions like this. So that's how we apply a filter. And yeah, so let's have a look of the content inside the packet. So at this window, you can see lots of packets. And in the middle side, we call this one is packet details. You can see the layering structure for each packet, the frame, internet IP, and the TCP stuff, and the payload of it. So you can find out all the like useful header for the packet. For example, I want to figure out what is the IP stuff. I should go to this part, the internet protocol version, this one. And if I want to figure out what is the TCP or UDP protocol header, and I should go here. Does this make sense? And yeah, and what is the payload of it? In here, it is a UDP stuff. Probably it is sending a picture to the server. So we can't see any meaningful stuff inside the payload. But if we can find the HTTP stuff, HTTP, we don't have any HTTP packets, but we will find it in our Lab4. Then you can see some meaningful payload in the packet bytes area. Okay, so I think that's all for the preparation. Just don't be afraid to use the Wireshark. It is very easy to use it, and you don't need to know anything about it. So let's open the trace file. Simply download the trace file in here. This one. Click it, download it, and drag it to here. So we can get started. For the question 1, I assume you have already know how to calculate this sequence number and ACK number, right? You should, because you have already done the midterm exam. So I think you have already know it. I will not spend time on it. Just go to the question directly. This part is asking us to open the file and apply a TCP filter. So just simply type TCP here. And yeah, that's all. So we can go to the question 1. What is the IP address of this stuff? You can see this one, 192.168, this IP address is our computer. And we are sending something to the outside. So that's the IP address of it. And this is the answer of question 1. And what is the port number for both sides? You can click a packet and then see the TCP protocol here. Then you can find the port number of ourselves and the destination port number, right? You may confused which one is our port and which one is the server side port. So because you can have a look of the number here is A0, which means it will always be a like HTTP server. When we browse a website like github.com, we didn't put a port number here, right? Because the default port number is 80. So when we visit GitHub, the Chrome will set the port number as 80 in default. But if you change it to another like number, let's say 81, we will not able to visit it. Let's open a new one. You can see we can't reach the GitHub, but we put 80, we will be able to reach the GitHub because this is the default port number. Sorry, probably get stuck. Let's try Google. It's not secure. Yeah, now it's secure. You can see the default port number for the HTTP server is 80. I should put this one. Yeah. So that's for the question 1. And let's go to the second one. What is the sequence number? We can find the sequence number in the header here, right? The sequence number, the raw number of it, and the relative sequence number. Yeah, but asking for the post command. So we need to have a look of the content of each packet by looking at this field. One by one, you can see here is a post command, right? You can see POST here. So this packet is sending a HTTP request. So what is the sequence number of this packet? It's very clear, right? You can find it. So let's come to the third question. This one is I think it's the hardest one for you. So you need to do some calculation of the this one, sample RTT and estimated RTT. I'm not sure if you still remember this equation. Let me find it for you. Yeah, this one, this equation. So in question 3, we will use this equation to calculate what is the estimated RTT. So if you still remember the content in congestion control, you will know why should we calculate this one. In here, this one, in here. So if we have a, let me show in here. You can see a calculated window size is in here. So what does this mean? The window size, because we have an algorithm to control the window size to make sure we can send as much data as we can at the same time. But we don't want the traffic, like the packet traffic is congested by sending too much packets to the outside. So we need to calculate a value, a dynamic value to send the packet to control the speed of the traffic. So how can we calculate the number of it? We use this equation. So in here, I would like to use Excel to do the calculation. Probably this one. I will delete the stuff in here. We will have a packet number and a sequence number and the length of the packet and the time we send the packet and the time we receive the acknowledgement and the receive sample and estimate RTT. So we use this table to answer the question 3 and 4. How can we do this? The first packet, where is the first packet? It's in here, right? This one, the post request. And what is the sequence number? You can find it around here. I will skip it. And what is the length of it? You can see the length is in here, 619, right? And what is the time? It's in here. The time is 0.0264. And what is the time of acknowledgement? So we need to find what is the acknowledgement for this packet. So how can we find the acknowledgement for this packet? Do you have any idea? Because the sequence number is 1 and the length of data is 565. So what should be the ACK number? It is not necessary to be the nearest acknowledgement. For example, this one. It says ACK, right? But it is not necessary the acknowledgement of this packet. We need to figure it out because by first one, you should look at the IP address of it. In here, you can see the source IP address is our machine, right? So the acknowledgement must be from this IP address, the server, to our side. So the fifth packet must not be an acknowledgement for this packet. And how about the sixth packet in here? Is it the acknowledgement for this packet? We need to check the acknowledgement number of it in here. You can see the 566. So 566 equal to this one, the ACK number, the sequence number, plus the length, right? So we can know this one is the acknowledgement for packet 4. So it's in here. So what is the time of it? It's 0.53. 0.3. So in here, then we can calculate the received sample. RTT should be this one minus this one. So that's the time the packet used to travel, right? And how can we calculate the estimate RTT? We have a equation here. So equal to this one multiplied by the estimated RTT. So what is the estimated RTT? Because here is the first packet, right? So the estimated RTT is equal to the received sample here, and plus this stuff, sample RTT. So that's how we calculate the estimate RTT for the first line. So we go to the second sequence number, second packet. So why we have like 6 packets in this table? Because we split a request, a HTTP request, into different packets. As you can see here, this one is the first one, this one is the second one, third one, fourth one, fifth one, sixth one, right? I'm not sure if we have 7th one, but you can have a look at it by yourself. So we split an HTTP request into different packets, then send it to the server. And the server can combine them together to get a full request of HTTP. So in here, we need to find what is the second packet for this request. So by looking at the sequence number here, right? Because we have already sent data worth 565 bytes. And this one should be the second packet by looking at the sequence number. And the length is 1514. 1514. And what is the time of it? 00.41. And what is the acknowledgement of this packet? We need to have a look of the other packets. What is the sequence number? Acknowledgement number should be is 566 plus 1460 should be around 2000, right? So let's have a look if we can find it. Yeah, I think it's this one because this acknowledgement number is equal to the sequence number plus the length of the data. So what is the time of it? 0.077. Then we can get the received sample. Right? And this one is the hardest one. How can we calculate the estimated RTT? Use this equation. So equal to this one multiplied by this stuff, the previous AST RTT, right? And plus sample. That's how we got it. So we use this two value. Sorry, stocked. Sorry, get stuck. But in here, we can know that the estimated RTT is calculated by the received sample and the previous EST RTT value, right? So make sure you can understand how we calculate this one. We use this value and this value to calculate this value. And you just keep filling the stuff here like this, and you will be able to answer this question. Okay, but you need to make sure the time in here is right, because in here I have changed a little bit. You can see it's not the exactly number as in the table. So you need to change the stuff in here. This value is not right. You need to correct it and redo the calculation. Okay. Let's see, we have another question here. What are the sequence number? Why are the sequence number the same? I'm not sure which sequence number are you talking about. The packet 2 and 3? No, they are not the same. These two, right? This one, the sequence number here, the ISN initial sequence number. I think you are talking about this one. Or this one. Can you specify the packet number? The sequence number is in here. Five six six. This one, right? Are you talking about the sequence number equal to 566 here? With yeah, different. This one is sequence number equal to 1. This one is 566. There's no same sequence number here. If you are talking about this one, sequence number equal to 1 and sequence number equal to 1 in here. I'm not sure if you are talking about these two packets. They are both have sequence number equal to 1. This one is the relative sequence number. Yeah, but you can see the IP address is different, right? For the fourth packet, you can see the IP address is from our computer to the server. And the sixth packet here is from outside to our computer. So it's in two different ways. I may show you the slides in here. Let's have a look of the slides in here. Then you may figure out what happened. In here, let's say in the left side is our computer and the right side is the server. So we will send a staff. Sorry, let me draw something. We will send a staff and we will specify the sequence number as X, right? Because the X is our initial sequence number. And when the server wants to send me something, they will set the sequence number as Y because Y is the initial sequence number for the server. So we are using different sequence number for each site. if I want to send something to the server, then we will use the sequence number based on X, right? We will do some calculation on the X according to the data size and the packet amount. But if the server want to send me something, it will use its own sequence number. So we are not sharing the same sequence number here. We both have a sequence number for each side. But the acknowledgement here will relate it to the sequence number from another side, right? That's how we use the sequence number. You should aware that we have a different sequence number for both sides. And yeah, the other question is why X number equal to X plus 1 when the data is length of 0? Yeah, it depends. If we are sending a thing or the thing, I'm not sure if you still remember the thing and thing. The thing, which means establish a TCP connection, and the thing means close a TCP connection, right? Both of them, they worth 1 byte. So that's the reason why we need to plus 1 here. Even we didn't send any data in this packet, but the thing will worth 1 byte, sorry. And as well as the same. We will have a look of it later. Don't worry too much if you don't understand it, because we will have a question related to this problem. But in here, you should just aware that the sequence number in both sides is different. So that's the reason we can see both sides have the same sequence number. This one is the relative sequence number. But when you click the packet in here, you can see the raw sequence number here. I can right click it and apply as a column here. So you can easily find what is the sequence number for each packet by looking at this one. So you can see the sequence number is start from AA3, and another sequence number is start from 2321, right? We can see there are two different kind of sequence number in this traffic. This one is from the server to our computer, and this one is from our computer to the server. So just fill the sequence number here, and yeah, just fill this table, like how we calculate the estimated RDP. And you'll be able to answer this question. And as well as the question 4, because we have already done this stuff, right? In the table, what is the length of each first 6 TCP segments? It is already in the table. And what is the minimum amount of the available buffer size? So what does this mean? It is the window size, right? It is asking something about the window size. So how can we find the window size? It's in here. Just right click it and apply as a column. Then you can see the number for each packet. You need to find the minimum value of it. Just looking around for the minimum number of it. I guess it's probably this one, not sure, but you need to double check of it. So the calculated window size represent the how many bytes should we process at the same time? Should we send at the same time? So this one is used to the congestion control. We want to send as much packet as possible at the same time without any like traffic problem, without any congestion. So we use a dynamic algorithm to calculate this value. And all you need to do is figure out what is the minimum number of it just by looking at the table. And question 6. Are there any retransmitted segments in the trace file? How can we find the retransmitted segments? What is the retransmitted segment? So if we send the data like 2 or 3 times, then the content inside should be the same, right? If we resend the data, the sequence number and the data length should be exactly the same. So we just need to look around if they have any packet, it's the same with each other, with another packet. To just compare the length and compare the content inside it, like the sequence number and the other parameter inside it, and see if we can find the 2 packets, they are exactly the same. Since we didn't find it here, but you need to look around until the end and see if you can find any duplicate content. So this one should be easy for you. And how much data does the server receive typically? How can we calculate how much data? How much data? By looking at this table, do you have any idea? And can you identify cases the receiver is hacking every other received segment? But we will need to have a look of the packets and the hacking stuff. So we just have a look of the content we send, like this one, stuff on here. We need to see if every packet from our side to the server has a acknowledgement. You can see this one, the acknowledgement of this packet is this one. And what is the acknowledgement for the 5th one? Probably this one. And just look at them one by one. See if we have a acknowledgement that acknowledging for two packets. Let's say we send the packets, we send 2 different packets, but we only receive the acknowledgement for the last one. So we omit one of the acknowledgements. So all you need to do is look in them one by one to check if there are one acknowledgement that responds to different acknowledgements. So, and the last one is question 8. The throughput. How can we calculate the throughput? throughput will equal to the how many data have we transferred and divided by the unit time, right? In here. So at first we need to figure out how much data have we sent by looking at the acknowledgement number or the sequence number by in the end. So what is the end of it? I guess should be this one, right? This one, the acknowledgement number is in here. So the acknowledgement number equal to 164091, which means we have sent this much bytes from where to where? From our side to the server, right? Because this one is acknowledgement. So what is the time of it? We need to have a look of the time. It's in here. 455830, 5.455830, and we need to minus when we started. So when we initiate the post request, it's in here, right? So we start from the time of 0.023172. We start from here instead of start from time 0. So we need to do a calculation here. What is the duration from the package, the second package, to which package? To this package to the 202. That's how many time we used and how many bytes here. You can see the acknowledgement number is 164091, which represent this much bytes. But you should also aware that when we establish or end the traffic, the TCP connection, we will also consume one of the bytes here. So that's the reason we need to do the calculation. We need to minus 1 with this number, right? So you must to remember minus 1 in here. And also calculate the time in here. We start from the packet 2 instead of packet 1. So that's the hardest part for this question. Just remember to get the correct duration and the correct size. Let me see if I have any question. In the TCP header, we have received buffer size. What that is referred to? The buffer size, we use the buffer size in here, right? You can see the buffer size is this one. So how can we get this number? Like you can see, they have different window size in different packets like this. So how can they calculate it? So when you dump the stuff in here, then you will know how they calculate the estimated RTT. So for the buffer size will be the similar calculation like this. So our computer is calculating the buffer size automatically according some equation like this to get the best value to transmit the data. And yeah, that's all for the question 8 and exercise 1. If you have any doubt, just let me know. The hardest part of this is question 3 and 8. These two question is the hardest one. So if you have any doubt, just let me know. Just make sure you understand all this content in here. Like in question 8, why should we -1 for the byte for the size of the packet? And why should we calculate the duration of the time instead of using the packet time directly? Okay, if we don't have any question, just come to the second exercise. For the second exercise, should be easier than the first one because it's purely calculation. Let's come to here. Just a quick review of how we calculate the sequence number and acknowledgement number. So for the host A and host B here, we want to send a data worth 1 byte from host A to host B. How can we calculate the number of sequence number and acknowledgement number? So how can we get the 79 here and here? Because the acknowledgement number is 79, right? So that's we calculate the sequence number. And how can we get this acknowledgement number here? It's equal to the sequence number in here plus the length of data, which is 1 byte, right? So that's how we get 43 here. And we also send the data inside this packet and it worth 1 length. And so we can get a sequence number from here and the acknowledgement number by plus these two stuff. Does this make sense? Just a quick review of it. So let's just back to the table here. For the question 1 and 2 should be pretty easy. What is the sequence number? Sequence number is in here. It's in here, right? This one is the sequence number. And what is the sequence number for the signac? So just find the signac at first. This one. And what is the sequence number? This one, right? And the question here, question 3, does this segment contain any data inside it? So how can we determine if this packet has any data or not? It doesn't say anything, right? It doesn't say how much data inside it. So how can we figure out by looking at this table? You can see if we have data in the previous packet here, then it will represent it in the acknowledgement number here, right? Because it will calculate like while the sequence number and the data length. So we need to see what is the acknowledgement of this number. So what is the acknowledgement for this one? Then we need to find it. Because the sequence number is this one, we need to find the acknowledgement in here. Right? You can see it's different. It's 1 byte different. Right? Oh, but are we looking at the correct packet? Let me see. What is the sequence number of the ACK segmented? Okay, sorry. We are looking at the wrong packet. So for the question 3, which one are we looking at? We are looking at this packet, right? We are looking at the response of the SYNAC. Looking at this packet here, it is asking any data in this packet. So we need to have a look. What is the response of this packet? Need to find it at first. So because the sequence number is this one, so we need to find an ACK, an ACK, ACK, which have the acknowledgement or near to this sequence, right? You can see where is it? Acknowledgement number equal to this one. Let me find this. Oh, we don't need to have a look of the response of it because you can see this one, the packet here. It's also from the client to the server, right? And you can see the sequence number didn't change. And here, this number, these two, is the same, right? So if we send the staff, send any data at the packet 297, then the sequence number must be changed, right? So because this sequence number is equal to the previous one, which means we don't have any data inside this packet. Right? So we can get the answer through these two packets, 297 and 298. Does this make sense? The meaning of psi, you can check it online, just as kind of response. Yeah. In here, we only need to know what is the thing, what is a thing. That should be enough. Just aware the thing is build the connection and the thing is finish and close the connection. Okay, let's have a look at question 4 here. For what is the what active close? Oh, so it's related to the closure here thing, right? The thing is related to the closure. So there are two packets have the thing flag. You can see from here to here and from here to here. So we have a thing from client to server and from server to client in 2 packets. So what happens? We can see they are sending the thing to each other almost at the same time. We can't say they send it at the same time, right? But we can see the acknowledgement is after the thing has been sent, which means they almost send the thing before receive any response. So let me draw something. The scenario should be like this. This one is the client. This one is the server. Yeah, like this. The client is sending a thing to server, and at the same time, or probably a little bit later, it also send a thing to the client, also a thing. And they respond to each other when they receive the thing command like this. That's what happened in the table. So we call this simultaneously closure. It should be, you can find some content in the slide, in the lecture slides for this kind of scenario. So yeah, that's all. With this figure, you should be able to figure out what happened with this question. And for the last one, question 5. How many data bytes have been transferred from the client to the server and from the server to the client during the whole duration? So similar question as the previous exercise. How can we calculate the length of the packet? How many bytes have we sent? So just have a look of the last packet. From the client to the server, right? Let me see which one is the client. The client is start from 109. Okay. This one is client. So the last packet is at here. What is the sequence number of it? It's this one, right? And we need to find the first packet from the client is in here. And what is the sequence number? So we just do some calculation based on these two sequence number. What is the difference of these two number? Right? Open a calculator. Yeah. 2 minus this one. Right? That's 34. In my side is 34. Did you get 35? Why should you add +1 in here? So how many bytes have we sent? So we can see the sequence number difference is in here. So what does this mean? What does this mean? I'm not sure if I need to draw something. Actually, we need to minus something at here because we send a thing packet here, right? This one is the thing packet. So if you still remember, the thing packet will count as 1 byte, right? So we got 34, but actually we need to minus 1 at here because this thing packet is count as 1 byte. Of course, you can also have a look of the acknowledgement number here. You can see if you use this thing to do the calculation, 653 minus 618 equal to 35, then you need to minus 2. Do you know why? If we use the acknowledgement number minus the sequence number at here, you will get 35 as your answer, but we need to minus 2. So why should we minus 2 at here? No, it's not because the acknowledgement equal to 1 byte. As I mentioned before, the thing equal to 1 byte, right? At here, this one is 1 byte. Sorry for the ugly writing. And what is the second one? It's the thing, right? So this one is also equal to 1 byte. In here, here, we didn't calculate the thing value of it, right? Because it's a sequence number, not the acknowledgement number. So it doesn't count the thing stuff. So if you use the last one, acknowledgement number, then you need to minus 2 because we have a thing at here and thing at here. So we need to minus 2. Does this make sense? It's not because the acknowledgement have 1 byte. But you can also understand like this. It doesn't really matter. Okay, so that's how we calculate how much data from the client to the server, right? But what if for the server to the client should be different, right? We only calculate one side of it, so you need to do another calculation for the server side. Let me give you some hints, but I will not do the calculation for you. You need to figure out by yourself. We have already done the client to server part. So what is the server to client part? We know the server is this one, right? This one. The server is this one. And this one. So the first packet is in 296. So this one is the crucial one. And what is the last one? Probably this one is the crucial one. So we will use these 2 packets to calculate how much data have we sent from the server to client. So if we are looking at the last packet, 306 here, we will have a look of the acknowledgement here, right? If we can use the acknowledgement minus the sequence number, what will be the result? And how many bytes should we minus the result? I'm not sure, but I think you have already know the answer. And that's all for the exercise 2. Yeah, just let me know if you have any doubt. And for the exercise 3, we don't need to do the submission for that. So just follow the command here, ns stuff, run at the VLab, simply download the file at the top of this page and run this command. Then you will see a simulator. Then run the simulator. And that's all. Just follow the command line here and play around with it, because in next lab, we will use this simulator to answer some question. But it will not be very hard. It's just a simulator, like Wireshark stuff. Just click it. Then here, just make sure you understand all the content in exercise 1 and 2, because we need to make a submission of it. And let me know if you have any doubts. And if you don't, you can also feel free to ask any question related to the assignment or other stuff. We still have like 40 minutes. If you want to have a look of the assignment or not. Okay, for the assignment, because this one is really, really long, right? How many pages do we have here? Gosh, 15 page. Yeah, that's too long. So because I haven't had a look of it yet, but it's quite similar as the previous year. So let's have a look how we do the assignment. Probably I can do some preparation for next week, because we still have 4 weeks, right? I guess I can make some preparation for the assignment in the future weeks, and yeah, spend some time on it and help you to get started. But here we just have a look of it. How can we getting started? I'm not going to read through all this content here, because it seems like a messenger, right? We need to design something like allows us to chat with each other. So we will have a server and several clients that will be allowed to log in and send a message and start private message stuff, etc. So at first, I will have a look of the marking criteria. Probably here, this one, marking policy. Then I will see what should I do in this program. At first, you can see the 1, 2, 3. This 3 is for the login, right? For the login function. So we will just start from here. We will design a client and server that can communicate with each other and allow the client to log in to verify their password. So let's just try to achieve this one. So how can we do to achieve the login function? I think they have some multi-thread codes here, right? Here I just download the server and client stuff. Let me open the WeLab at first. Let's try to do the login function, but not sure we have enough time. I'll come to this page, go to the WeLab. WeLab here. Because we have already have some example code, we just simply download it, and we don't need to worry about the plagiarism. What is the stuff? I don't know. Download it again. Now we know. So we have a server and client, right? We will build our program based on this stuff. So let's do some design at first. Try to draw something, draw the server. And we will also have a client. And I think we also have a, what is the file name of it? Let me check. It's in here, credentials.txt. So we have these 3 stuff as our file. Like this. I should put it like this. So what should we do in here? We have a server and client and a file called credentials.txt. If you have the look of it, it have some username and the password, right? It's just like a database, but it is in TXT file. And the credentials should save in the server side, and the server should be able to read and write it. And we want to achieve the login function. So we are required to send the message from client to server and from server to client. The client should be able to send something like login username plus password. Should be able to send something like this, right? And the server should be able to send a response. Login, let's say failed or success. Sorry if I have any syntax error here, but that's what I want to say here. So we need to modify the syntax like this. So basically, we want to design a protocol that allowed our client and server communicate with each other. So we need to design a syntax like this. How can we send a message from the client to server and they can understand with each other, right? That's the challenge. So in here, we just want to have a look of the code. And play around with the code at first. You can see we have already had a template for this one. That's great. We don't need to code start from zero. We have a server. If we can run it, let's see if we can run the server here. Run. We need to run the server with the port number, right? So we can open a terminal like Python 3 TCP server. Server is running, waiting for the connection request from the client. Then we run the client here. Python 3 TCP client and the port number, I guess, and the IP address, probably. Okay, that's great. You can see it says we got a connection from here, and we type some message. Hello. That's great. It have a template for us because it have already achieved the send and receive message, right? And you just continue here. Let's say log in and the username admin. And the server side can receive this message and print it here. So we need to change the server side to understand this command in here. Let's say, let's see how they print the message here. The login. Oh, it says if message equal to login, then new login request, process login. It will call the login function. Let's see if we can type login. Login. You need to provide the username and password to login. Yes? Oh, doesn't make sense. Oh, so we need to complete this part. We need to complete this part, right? Just modify the code in here to check if we can verify the username and password in the credentials. So we need to add something here. But I don't want to show you the code because if I show you the code, you can just copy them. But that's how we do it. I can write some hints here. When we get a login, then we can ask this one to send the first stage should be ask client to send the username. and the second one to ask to send the password, and the step 3 should be verify, right, like this. So we need to add some code at here. And we need to also modify here. If receive message equal to none, equal to this one, credential request, you need to provide username and password to log in. Then we can message. We want to send this stuff. So the message will equal to the username, the input username, as well as the password, something like this. Password equal to input. Okay, like this. And we need to put the username password into the message and send it to the here. Message is equal to the let's make it a tuple. No, probably not a tuple because we need to encode it. Should be a string or something. Let's just make it easy. User name, a space with the password. Let's make it like this. So we will send the message, including the username and password, to the server and see how it goes. And yeah, and then we should be able to get the result of it. And let's print the data here. Right? We will print the results from the client. Print username and password is are. See if we can print the username and password in the server side. Okay, save and run it again. Let's see if it will work or not. Run the code and we send a login at first. Yeah, and it asks us to put a username here. We say admin, and the password is admin password. Oh, sorry, I didn't put the right stuff here because what is the problem here? Seems it doesn't print the username and password here. Username and password are okay. Okay. The problem is at the client side. I didn't put it in the bracket. That's my fault. Username and the password. So now should be okay. and let's log in and send the username. Username is admin and the password is 123123. And you can see our server side will be able to receive a message containing our username and password. Then we can add the verification of it, right? We can add a verification in the server side. So the username and the password equal to the message dot split, split by the space, right? But it's not a good idea to split it by a space. And we can do some verification. Let's do the verification. The verification should be very easy. You can read the txt file, but I'm not going to read the txt file here. I will write a if closure here. Let's say if the username equal to the admin and password, let's say we set the password as 123123. Then we can say login success. Log else. Else like this, and we can also send the data back. We can also send the response to the client in here. Put like this, and here login out. Sorry for the syntax here. Okay, let's see if it will work or not. In here, I've set the login details in my code, but you should be able to read the txt file here. And that's the verification. And let's see if we can run it again. Oh, sorry. The client is in here. And then we can see if we achieve this problem. Let's say login, and for the username admin 123123. It says login failed. I don't know what happened, why it failed. It should be okay. So I guess we have some problem here. If equal to admin and 123123. Not sure what happened, but let's try another one. Yeah, login ASD AS. Oh no. Yeah, login ASD. Okay, so I guess the if it has some wrong with it, so I need to fix this part. Probably by checking here, we can print the username is username, and the password is password. to see what happened. Logging NAS admin CSN 123. Okay, that's the reason. We have a plus inside here. Where's the plus? Why we have a plus here? Oh yeah, it's in here. Too stupid. I guess, yeah, just like this. This one should be okay. My bad. Okay, so that's way to do it. So login function, then we can log in. The username is admin, and the password is 123123. Oh my gosh, another problem. It says I had made a mistake in server side. It is not able to password. It's not defined. Yeah, I need to check if the password is right or not. Yeah, let me see. Because oh, sorry, you can see I made a mistake on the name of the password here, right? The password is PSW. So you need to check all this problem here. So I made a lot of mistake. I'm sorry, but yeah, it's really hard to avoid the problem like this. So login the admin 123123, then login success, right? And we can send something or set the stuff in the server side and make another connection. Let's say login username is Xiaoming, the password 123. We will say login failed. Okay, so yeah, that's a very simple version of login function, but yeah, it's incomplete. You also need to modify more of it. But in here, I just want to do a demonstration of how we modify this like example code here. So just don't be afraid of it. I know the specification is really, really long. Looks very scary, but we just need to start from the like simplest task here. You can see at least I get 1 point from the assignment here. Probably not 0.5. So it's not really hard, but you need to spend lots of time on this assignment. Just getting started for now. So if you have any doubts and questions, feel free to ask me during the lab or post it on the forum. Yes, the whole program is not very hard, but you need to make sure you have achieved all the tasks here. Like here are some examples at the end, sample interaction. So you need to strictly follow the syntax here. So at first, we are required to log in. You will ask the username and password of it instead of type the login stuff, right? We still need to modify the program. Just have a look of the example here instead of looking the specification at first, because it's very hard to read through it. Let's just get started from the example. And when you implement this part, then you can go to this part and have a look. For example, here, for the authentication, the login stuff, I need to read. That's all. Yeah, just let me know if you want me to show anything about the assignment uh, today or in the future labs. And I'm not sure if you are from the CSE faculty or from non-COE faculty. I think most of our students are from the CSE faculty, right? We have different tasks for the CSE student and non-CSE student. So for the CSE student, we are required to do the P2P messaging part, which means like you will have a client that need to communicate with each other directly instead of communicate with server. So if you are a student from other faculty, you only require to implement client to server side stuff. So the client, if you want to send a message to another client, you will go through this. Client will send to the server, and the server will send a message to another client like this. But if you are a CSE student, you are required to do like this. Client send the message to the client directly. Seems very easy, but yeah, a little bit complicated. You need to have like multi-thread stuff. The structure will be a little bit different for the program. You need to handle different stuff at the same time if you want to implement P2P function. Probably I can bring more example or structure in the future labs. Let me know. Yeah, that's all the content for today. If you have any question, just feel free to stay here. But if you don't, we'll see you next week. Thanks for coming.